Matplotlib has this idea of a figure and an axis, and how do I ever think about laying things out on them? I want to be able to add axes wherever I want. I want to be able to draw plots the way I want them to look, such that it's convenient for me. In one level of the interface, you have a position-based interface. And what we can do here is we can create our figure, our blank canvas, so to speak, and we can add axes wherever we want. We've actually seen this before. And when I add axes, right, I specify that lower left corner, and I specify the width and height, and I can put axes wherever I want. I can even put multiple axes, and I can track these using the object-oriented interface, and everything is good in life. But let's be honest. How often do you make inset axes onto a parent set of axes? Not very often. I only do this if I'm making, like I said, an infographic, something very specific and a powerful visualization that's used to convey information to a very broad audience. If I'm giving this just to, say, my boss, just for a quick look, I would never really use inset axes. And so maybe what I would do is I would create something more useful would be create a grid of plots or side-by-side plots even. And you can see here I can use this position-based interface to do this. I specify my number of rows, my number of columns, the amount of space that I want between each of these plots. I do a little bit of math to calculate what should be the width and height of each of these plots, and then I simply add them to my parent figure. And you can see here that I can add a grid of plots, removing that off diagonal if we're thinking of this as a matrix, but I can make a grid of plots and I can organize and lay these out in any fashion that I want using this position-based interface. But what's not convenient is all of this code, right? Specifying rows and columns, sure, that's great, and the space between, but this math here, who wants to be doing this? I had, setting up the width of your entire figure, subtracting 0.1 so you have margins on either side, and then figuring out the math to calculate the correct width and height of each of these plots such that they're square in a square-based grid. It's not convenient. And if there's one thing that we know about Matplotlib is it has layers of convenience on convenience. So what we tend to reach for is actually a grid-based layout. Whenever we want to lay out plots, in a 3x3 or a 3x2 or a 1x2 fashion, we can use this grid-based interface. And so the access point here is figure.add subplot, and all this does is creates a set of axes on a given grid within your figure. And this grid is created implicitly here, but what I'm actually doing is say create a 1x1 grid and then put the axes on it. Pretty simple. Now, if I want to create something a little more complex, I can create a 2x1 grid, 2 rows, 1 column, and then, 2 rows, 1 column, and then put my set of axes in that grid. And what this last argument here is the index position of where that axis should go. And if we think of a 2 rows by 1 column structure and we start numbering the cells in this matrix, we would, starting at 1, the top would be 1, and the lower set of axes, or the lower grid space, would be 2. And so we can use this idea of a grid system and indexes to create plots wherever we want them on this grid system. And now this is very convenient because I can do things like create 2 rows, 1 column, create a grid with 1 row or 2 columns. You can even get some of the functionality that you would expect to get from the positional-based interface. I can mix grids, so this is a 1x1 grid, and then this is a 3x3 grid, putting it in the third spot. And now you have to think 3x3, that's 3 rows, 3 columns. Now you have to count for the index. The first one is top left, second is top center, third is top right. And so when I put these axes down, I can see that I put my another set of inset axes, but I'm using this grid-based interface. The other thing is that you need to be careful about the order that you put it in. If I were to add the inset axes before adding the parent axes, we'll actually cover up the inset axes. So just a couple gotchas to watch out for is the layering in these things. And you can use just a little bit of logic to create plotception, so to speak. You can just layer axes within axes if you want. This grid-based system is quite flexible, right? It's not orthogonal to the positional system. You can do pretty much anything in both of these systems. It's just which one is more convenient for you to work with. Now, the thing that I really like about the grid-based system is that you can use it to span multiple rows or columns, kind of like a row or column span. And so if I wanted to create a set of axes or sets of axes that go from the first to third row, the first to second row, and then the first to first row, I can do that using this grid space, using tuples of indexing, I should say. But if there's one thing that we've learned from other libraries, NumPy, even using a list, let's be honest, how convenient is it to say, let me draw a set of axes from the first to the 7th index. I have to sit there, which one's 7th? Oh, right, that's the lower left corner, and the first is the top left corner. That's why that first set of axes spanned 3 rows. What I like to use is the grid spec object from Matplotlib. Here you just specify your number of rows and columns, and then you can very conveniently use indexing to add plots to your figure. And so in this example here, I am creating one set of axes that spans from all of the rows in the 0th column, or the first column, and then my next set of axes will span the first 2 rows in my 2nd column, and then in my 3rd column, I'm not spanning any rows, I'm simply just putting it in the 3rd column. And you'll see, once I cover that up, you'll see that I get the same figure that we saw before, where I no longer have to think about the first to the 7th index or the 2nd to the 5th index to create these. I can think exactly how I would approach a NumPy ND array, 2D array, or a nested list. And so this grid spec offers us great convenience. Now, one thing that I want to also share with you is yet another layer of convenience Matplotlib gives us. And that is, you'll see this pattern repeatedly, and that's why I bring it up. That's because Matplotlib has to add and register every child to a parent container. So if we think of the figure as our broadest, most external container, anytime we do any drawing on it, anytime we add a grid spec or anything on it, Matplotlib has to register it. And so they add these accessors, these very convenient kind of object creation or child creation methods to almost all of the higher level container objects. And so instead of manually creating a grid spec from a grid spec object and then adding that to the figure, I can simply figure.add grid spec. And this takes all of the same arguments as the base grid spec object, but I circumvents me one import, and it gains me just a little bit more clarity into where this grid spec's going and how I'll be using it. Here I'm just demonstrating just a few more of the arguments that you can give to grid spec. You can specify the ratio of the widths and the height from your grid. So this is actually a 2x2 grid, and I've just specified the left-hand column to be 1.5 times wider than the right-hand column. I've said put 2 units of spacing between the plots so they're nice and far away from each other, and then bring that right margin in just a little bit so that it spans 0.8 of the figure, and bring that bottom up just a little bit as well so it starts at 0.2 of the entire figure. Matplotlib also has another convenience layer, and this is the one that I use the most often. This is the subplots entry point. So if we're thinking in terms of how can I generate a figure and some axes in a convenient way, this is what PyPlot to me does the absolute best. We can instantiate the figure from the figure method. We can instantiate a figure from subplots. And what's convenient about this is that we're actually mixing some of the interfaces we've discussed. Subplots is purely a convenience wrapper around create a figure, add a grid of axes on it with a grid spec. And so if I were to write this method from scratch, it would look something like subplots, and I would give it some arguments, and the arguments are simply n columns and rows, right? That's 3x3. And then I would capture grid spec. So we're actually creating a grid spec here. This can be an empty dictionary just for now. The keyword arguments that are passed when you create each subplot, remember we're using that add subplot method. And then all other keyword arguments are passed to the figure object itself. And so if I were to use Matplotlib interface, we would create a figure here, right? And then we would actually iterate over the rows and columns. And that would be range. And then we do our actual subplot addition. And what we can do here, we would make our grid spec, and we would pass it those grid spec keyword arguments. And then we would actually finally add our subplot. Right, ij. And you get the idea of this is actually, if you were to look at the source code for Matplotlib, it's not exactly this. There are a couple more arguments to subplot, share x, share y, and things like that that are passed in. But this is the main logic. This is why we call this a convenient method. And we end up returning the figure and returning the axes that we create. And it's a very easy way just to set up a grid without having to explicitly say, okay, give me a figure. Okay, now give me a grid spec with 3x3. We just get it all in one method call. And so if I were to show this, we see I do in fact get a 3x3 grid, just a very convenient entry point. And now that's not my favorite entry point though. My absolute favorite entry point that I recently learned about just a few months ago and can't stop using it is Mosaic. Subplot Mosaic allows you to create a visually based representation of what your axes will look like when you draw them. And so if you were to look at this visualization, you'll see I have 4 unique characters, A, B, C, and D. And this is actually telling Matplotlib that I want 4 unique sets of axes, one on the top left, one on the top right, one on the bottom left, one on the bottom right. Not specifying number of rows or number of columns, that's all implicitly done here just by having this 2-dimensional or nested list, so to speak. If this were a NumPy array, it would be a 2-dimensional. And so when I draw this, we see I end up with a 2x2 grid of axes. And what I absolutely love about the Mosaic interface is that if these characters are non-unique, you can see here I have A in the column, the first column, and then unique characters in the second column. Matplotlib will actually interpret this as me saying, I want 3 plots. This first column, I want to be just one tall plot, and then in my second column, I want 2 smaller plots as part of my 2x2 grid. And you can specify this visually and very succinctly in a way that allows you to lay out plots really easily. What's even better, more powerful in my opinion, is the ability to not just use A, B, C, and D, right, just pointless kind of naming conventions, but to use part of your data that's related to these plots. In this instance, these could be coefficients, they could be multipliers, right? I want to view my data based in different ways. And so I could say, for this plot, or for this axis, right, multiply my data by 1. In the top right, multiply it by 2, 3, and 10, so on and so forth. And you can actually see the power of this. What's returned here by subplots Mosaic is the figure object itself, but also a dictionary of axes. Whereas the subplots, not Mosaic, right, that returned an ND array of axes. The dictionary is very convenient because it allows you to tie data or labels into your axes, allowing you to perform very convenient operations. So in this example, I'm saying that my mosaic of 1, 3, 2, and 10 are actually coefficients or multipliers of standard deviations, I should say. And we'll use that to actually scale some randomly generated data. And you can see here that I've used the naming convention, right, of subplots Mosaic to actually perform something concrete on my data without having to use any fancy functions or odd dictionary namings and mappings. I'm able to actually just tie in multipliers or coefficients straight into my representation or my visualization of these data. And that's what I love about subplots Mosaic, and that covers how you can lay absolutely anything out on your figure in Matplotlib.